So apologies for the last video being cut short. Um, so let's get into this. So what's happening here is because we are looking at this, we have an angle. We know that it should be in the second quadrant. So the angle is always going to be relative to what we're talking about. So that's where you saw me with my confusion later earlier. So we have some angle that's relevant here. It's like there's a wind force here. So we have to use our own logic to kind of think about this. So the airplane is going this way. So we know it's in quadrant two. So we want an angle. We need to know that the angle is somewhere between 90 and 180 degrees. So this is going to be our range for where the airplane is actually going, because obviously the wind isn't going to blow this so far south. So it's just a relative angle, and that angle is going to be relative to like here. So that's why we have this confusion here that there's an angle here that's kind of messing everything up. So what's happening is that angle, it's resulting from here to here. We need to figure out where it's actually going relative to 180. So what we're going to do is we're going to take this angle and subtract it from here, and that'll give us our angle right here. So it's just weird how it's set up, but you do have to kind of use your own thoughts when you're doing this. So that's why when we do the work, we do get this angle here, but that angle is from west. So we're going to take that angle and add it to the 180, and that'll give us something that falls within that 90 to 180 range. So, does this make sense? And you would answer yes after, well, initially, no. So, at first, it doesn't. So, that's what I'm saying. Initially, no. But once we factor in logic to know where the angle should be, it does. So these are all tools that you have to kind of like use your own thinking towards. So unfortunately, I didn't get to finish that before, but this is what's happening here. So once we get that resulting angle, we get that angle from this right here. So that's why we have to kind of use our logic to put that together. So, and they talk about how it's slightly less, like the wind is affecting it a little bit, but not too much. All right, so let's go into the rest of the lesson. Um, the, this drawing tool, I think, always kind of like scrolls it down for me for some reason. All right, so now we're going to learn about how to do this with actual distances. And the thing is, because it's trig, you'll get these weird numbers, but you can always just divide those out and make it better. So this is, in math, they usually don't like square roots at the bottom, so they rationalize it. But I always thought that's funny because you can just multiply this out also. So it's all weird. I don't know why they're picky about it, but let's get into more of these. I think these make sense. The only thing is when you're dealing with like flying and stuff like that, it's always annoying because they're doing angles relative to other angles instead of just like, hey, let's just always do east. But that's just how math is. It's set up this way because we're used to this. So we're used to left and right. So when we go in the real world, it's you kind of have to move stuff around. So I'll let you guys read this on your own. It's basically the same thing. Just remember that the magnitude just means how long something is. Cosine is used to multiply that magnitude, and that'll give you the length of your x. Same thing with the y, magnitude times the sine to give you the length of your y. All right, so you can also find the actual direction. So finding the actual direction again is if you already know what your x component is, you know what your y component is, you can get this angle right here. And just keep in mind it will be negative and you kind of have to use your own logic to do that. So obviously if your x is positive and your y is negative, you have to realize that it's always going to be based off of this off of the x-axis. So because it's based off of the x-axis, you're going to have to like add it to 180 to get this right here. Oops, I think I skipped one. All right, and then I always recommend these videos, guys. I know it feels hypocritical because I never look at them, but they are really useful. They explain it a lot easier. I just don't want to like just sit here and like, hey, check this video out when you guys can do that on your own. Because I assume you guys have this open uh, while you're watching the video, so you guys can watch that on your own. All right. So in the video, you saw velocity sailing ships. All right. So let's get into more practice. So we're going to have to figure this out. So first things first, the vector has a magnitude of that and a direction of that. Arrange these in ascending orders of their magnitude sums. Okay, so we need to figure out arrange these vectors in ascending order of the magnitudes of their sum vectors. Okay, so sum vectors are when so we're going to have to add those vectors together and then find the magnitude. So let's get into that. So first things first, we need to figure out the x and y components of all of these. So what we're going to have to do here is for t, we're going to have to solve for the vector t, the vector u, the vector, all of those vectors, and then we're going to have to add them together and then find the magnitude of them from there. So let's find the x and y components of this. So we're going to have to do 5 times sine 225 cosine, doing the x value. Cosine 225, and then 5 times cosine 225. And again, I recommend using Desmos. Go to math tools, not graphic calculator. Oh my gosh. Why would that be the first option if we could just click this scientific? So we're going to do 5 sine 225. I was supposed to do cosine, but we'll just do that for now. So I'm going to let's do the nearest hundredths. So -5, -3.54. So again, so t is equal to -3.54. Now we're going to do it for the x value. So for the x value, we're just going to change the sign, cosine, and it's the same thing. Oh, because that's a 45-degree angle. 45-degree angles cause it where we're going to have an equal x and y. I know it doesn't look like 45 degrees, but it's 180 plus 45 degrees. And it's also negative, so this is in quadrant 2. Because it's a negative, or quadrant 3, sorry. All right, so now we need to do u. So if we do u, this is going to be, so the magnitude is 3, and we're doing 60. So 3, let's do cosine of 60. It worked out 1.5. And then let's change this to sine. And that's 2.6. All right, let's do V. So this is basically like a lot of work that you kind of have to do just to have these organized. So we're going to do V, and V is 5 and 120. So I'm going to change this to 5 and change this this to 120, and I'm just gonna leave it as sine because I have to do the sine anyway. So I'm gonna kind of snake it. I'll do sine. I'll do a double sine, and then I'll do a double cosine just to get these done. I have to do this to cosine. Negative 2.5, negative 2.5. All right. And it makes sense because should be in quadrant 2. Now I have to do W. So W would be 4 and 240. 4 and 240. Make sure you're keeping track of if it's a cosine or a sine. So this is a cosine, so it should be the x value. And this is just because we're doing it in rapid succession next to each other. It's like it's faster to just kind of do whatever's there. Negative 3.46. Negative 3.4. I said 4.6 is 6.4. Oh no, it is 4.6. Oh my gosh. I anticipated my own dyslexia and then it didn't work out that way. Why aren't you? Oh, derp. I'm not using their tool. It's like, wait, this isn't even. 0.46. Sorry, I just have so many multiple tools open that I forget which tool is which. Now we're doing X. Oh my gosh. Why did they want you to do all this work for such a small part of the thing? Cosine. So that's negative 2. Oh, wait. 7 and 300. So I'm going to change this to a 7. And change this to a 300. So it's 3.5. 3.5. And then we're going to change this to sine. So unfortunately, it's just a lot of busy work, guys. I hope you guys appreciate I'm going through this and not just going like, I'm just going to skip to where he puts the answers. Comment down below if you guys are watching it and are like, hey, like I am watching it to hear you complain about people that might just be skipping this to the answers. I do want to help you guys out, so that's why I'm doing these. I just don't want you guys not learning just to get the answers. All right, so we have this here. All right, so I'm on the y value because it's sine 5. So it's negative 5.3, negative 3.53. Also, I appreciate when you guys do comments. It lets me know that people are watching this and appreciating it. At least a positive comment. Sometimes I get the ones where people just want the answers. All right. And let's see here. Magnitude is 3, angle is 120, so magnitude is 3, angle is 120. So that would be negative 2.6, and sine, this cosine, negative 2.6. Hopefully all of this is right and I didn't like mess something up because otherwise we're just going to look at their answers. I wanted to go through this though and show you guys the process of how to do it and not just, hey, here's Edmentum solving it for you. So here are all the vectors. Now what we have to do is we have to add all of each of these vectors together and find their magnitude. So that was the process of just finding the vectors. Now we want to add these together. So I'm going to do the TU, for example, and then I have to do TV and then TW and then TX, TY, TZ. So I'm going to, what I'm going to do is I'm actually going to solve this on a annotate so I have room because there's way too much stuff here. So give me a second while I go to annotate. All right. So what I'm going to do is copy and paste that right now. So give me a second while I snippet tool this. All right, so here are all our things, and we're going to want to add all of these together. So we're going to do negative 0.45. Oh, I really hate this calculator. Give me a second. Let me see if I have my scientific calculator. So I guess I'm gonna have to do it this way. Unfortunately, I'll just form them in a way that makes it a little easier because I don't understand why it's hard for people to program a calculator that can handle negatives. So negative 2.4. So negative 2.04, and this is going to be our TU vector, our T plus U vector, I guess you could say, comma, let me grab the calculator, um, 2.67 minus 3.54, negative 0.87, and then we're going to do a TV vector or T plus V vector. Um, let's take a look here. All right, so adding those vectors together, we're going to do negative 2.5 minus 3.54, negative 6.04, comma, 4.33 minus 3.54, 0.79, and then we're going to do it for TV. So this is supposed to be a W. I guess didn't copy it down right. So let's do TW. Well, from here, I'm assuming you guys understand the process. Then we're gonna do a x squared plus y squared. So, in the interest of saving you guys time, I'm just gonna solve the first one, and then we'll just move on from there, and we'll hop over to Edmentum's answers. Like I said, I really do want to help you guys out, but it's very repetitive, and I'm afraid I've probably lost some of you in all this. So let's kind of use Desmos here. So we're going to use Desmos to do square root of, give me a second here, square root of, oh, it's on annotate, parentheses. Because of that negative, I want to make sure I'm using parentheses to include it. 0.4 squared, and you can always click on it. I just use Shift 6 to do the exponent. Um, Plus, oops, make sure it's inside here because Desmos, when you get out, it moves it over to the next spot. Negative 0.87, I believe. 87. And we get like, so this is our magnitude overall. After doing all of that work, that's one magnitude. And then you would have to rank these in order. So you would have to rank all of these after doing all of this. So I find that's way too much work for something like this, but be prepared because it could do it, but I have a feeling they'll do it with like four things because seven's excessive. So you can see here all the work that they did. They had to find the magnitudes of each one, then they added together, then they added the magnitudes, square rooted it. So it's just a very long process. And I guess if you guys want, really want, you can always look at this explanation afterwards. But that's how you would do this. It's just very long, very tedious. All right. And with that, you can watch the summary video to get it all down. Most of it, honestly, guys, I would really recommend studying this. This is what everything kind of broke down into, this idea of finding vectors and their sums. All right, and that'll conclude Module 2. Um, we have I have the pre-calculus class today, so we'll probably do Module 3 in that. All right. Have a good one, guys.